today we're going to talk about a postulate for similar triangle. Okay. So Jonathan, why don't you read this for us right here?
You can always prove that two triangles are similar by showing that they satisfy the definition of similar polygons. However, there are simpler methods.
Okay, so we're going to talk about simpler methods. But the reason is because in order to use the definition of similar polygons, right? By the way, let's review a little bit. What was the definition of similar polygon? How can I use the definition of similar polygon to prove that two triangles are similar? Yes, one person remembers from last time? 2, 3, 4. All right. Okay. Okay. Tony?
All the corresponding angles are congruent.
Good.
And then the sides are in proportion.
Good. It has two parts, right? The definition. First part says corresponding angles are congruent and corresponding sides are in proportion. That's the second part. By the way, it turns out don't use the definition of similar triangles. You need, if you're going to talk about these things, it depends on which one you use. When you do this in your proof, I need you to write down the specific parts. So you need to say either if you want to say something about the corresponding angles that are congruent, you have to say, right? Similar triangle, the corresponding angles of similar triangles are congruent. You have to say it that way. Don't say definition of similar triangles because it has two parts. You got to tell me specifically which part you're using. What if you wanted to say that the corresponding sides are in proportion? What do you have to say? Corresponding sides of similar triangles are in proportion. You have to say it that way. Does that make sense? All right. So if I want to use the definition, how many things do I need to show? 2. Oh yeah, mainly 2 things, but 6 parts, right? Why do you say that's Samantha? You gotta show that the 3 pairs of angles are congruent, and you need to show 3 pairs of sides are in proportion. There's 6 things to say, right? They're saying that there is a simpler method. It's kind of like similar to, you know how you have to prove 2 triangles are congruent? Right? You gotta show, by using the definition, you gotta show 6 parts, right? But then we had what? Side, 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 side angle, side, and so forth. So similar to this, there's a simpler method. Anybody want to guess? This is a postulate that we're going to talk about. Jason? Yeah, it turns out if you have angle congruent, guess what? These 2 triangles are guaranteed to be similar. So that's our postulate, and it's got a name. Isn't that nice? It's called AA. Similarity postulate. Please don't forget that part. Similarity. People just write AA postulate. It's not AA postulate. It's angle similarity postulate. And it reads: if 2 angles of one triangle are congruent to 2 angles of another triangle, guess what? The 2 triangles are similar. Okay, so go ahead, write this down. That's the postulate that we're going to use. By the way, it's a postulate. So do we need to prove this postulate? No. It's a postulate. So we take it as truth. Okay. So write this down. By the way, this makes sense, doesn't it? Right? If you have 2 triangles and you happen to notice that one triangle, right, two angles of a triangle is congruent to 2 angles of another triangle, right? Guess what? What about the third angle? They have to be congruent too. We had a theorem or postulate theorem, I think, that said, right? Because some of the triangle is 180, right? So all 3 angles are really congruent, right? So the 2 triangles must be similar, okay? So this is a postulate. So knowing this, let's do an example. Is that okay? So here's our example. Take a look at this one here. Okay, hold on. Here we go. So it says H and F are right angles, and you have HK times GO equals to FG times KO. That's what we want to prove. So how can we do this? Okay. Yes.
How come we always have to prove it with multiplication? Why do we have to write HK times GO?
Right, so what does it mean? First of all, HK times GO. Yes?
HK over FG equals to GO.
Okay, so we're going to get there. Very good. But what does it mean when we have HK by itself like this? Yeah.
By itself?
Yeah.
Or the proof part?
Well, let's just stop right there. I think we're having some... Right? We don't really understand what HK times GO means. What does it mean if you have HK by itself written this way? Yeah.
HK equals FG times KO divided by G.
No. I guess you're going way far. I'm just simply asking, what does HK represent? Yeah, the length. We're just talking about the length of this side. So we're saying the length of HK, right, times the length of GO right here is equal to the length of FG right here times the length of KO. That's what we're saying. So how are we going to do this? So, no, not this one. We'll just look at this one together. Which ones?
The angle KHL. No, the angle HF.
Yeah, okay, first of all, angle H and angle F, they're both right angles, right? So what do you know?
90 degrees.
Yeah, they're both 90 degrees. You gotta say it this way. They're both 90 degrees, so what do you know? If they're both 90 degrees, then they are congruent. Okay, that's great. What do you know about other angles? Yes. Vertical angles are congruent. So angle 1 and 2 are congruent. So guess what? The two triangles are congruent? They're similar. Okay, they're similar. So what? How does that help us to get this statement where HK times GO equals 2? Oh, a lot of you see it? Okay, good. Go ahead. I'm going to give you some time to think about it as a group. What do you think? Let's first of all show why the two triangles are similar, because that's going to help us to get to the statement where HK times GO equals FG times KO. So first I'm going to say, I would put given. Did they do that? No, okay, they put 1, 2, doesn't matter. These two could have been switched, right? So because 1 and 2 are congruent, the vertical angles are congruent. H and F are right angles, that's given. Can I say as a third step then H and F are congruent right away? No, you have to say first they are 90. Andrew, why? Definition of right angle is exactly right. And so since they're both 90, guess what? They're both congruent. They're equal to same, right? Measurement. So definition of congruent angles, right? Right? So now we could say the two triangles are similar. Now, you have to say it carefully. Does the order matter?
Yeah.
Yeah, so if they say, let's see, if they say HKO, guess what? They have to say H goes with F, K goes with G because, right, that's the other, and then O goes with O, right? Those are the congruent angles. So there you go. Now, here's the trick. We want to say something about HK. You see this side right here, HK and GO right here, and FG right here, and oops, FG and KO right here. Do they mention anything about HO and OF? So do we even need to mention anything about those sides? No. So how are we going to get this statement? HK times GO equals 2 FG times KO. What's the key step? After we're saying that the two triangles are similar, what is the key step that you need? Brianna?
Like the GO to KO equals FG to HK.
Exactly. So you need to use those four segments that we wanted to, right, prove. We know some relationship with these segments. We know that HK to FG is equal to KO to GO. Would you not agree?
Yeah.
Why? Because what are these? Look at HK. HK to what? HK to FG. Are those corresponding sides?
Yeah.
And then what about KO and GO? Are those corresponding sides of these similar triangles? Do we need to mention anything about HO and OF again? No. They're not even involved in that statement at the end that we want to get to, right? So all we need to say is this. Because of what? The second part of the definition of? No. First, the statement 6. What's the reason for statement 6? Yeah, it's the second part of the definition of congruent triangles. Similar polygon, or yeah, corresponding sides of congruent triangles are in proportion, right? Not congruent. Similar triangles are in proportion, right? So therefore, if this is true, what can we say next? Amen? How do we get to the statement that we want to go to from here? Exactly. How do you, why? What allows you to say that? Yeah, because of a property of proportion. Isn't that right, guys? You guys remember this? This is kind of, yeah, so that's, but this, I would just use property of proportion, not easier. Okay, so you know that, right, this is kind of like multiplying the means and the extremes, but I would just use this. So you see that we get to the statement that we wanted to. Does that make sense? Do you see why they chose these corresponding sides on step 6? That's the key. Why do we choose these? Why couldn't we say HK2, FGS2, HO2, FO? Josh?
They're not corresponding.
They are. HO and FO, yeah, they are corresponding.
Oh, it's because it's not part of the.
It's not part of what we want to say at the end. Does that make sense?
Yes.
Okay, so that's the trick. Any question? So whenever you see these kind of things, guess what? You're going to need similar triangles. Yeah? And then you're going to say the corresponding sides of similar triangles are in proportion and so forth. Okay? Can you do something like this on your own? Now that you have this example? Yeah. Okay, this one, now I'm going to give you the second example. Go ahead, try this. This is very similar to this, but it will test and see if you actually got this, okay?
Can you write it?
Yeah, this one you're going to write. Okay, hold on. Here, let me give you a very similar one as the one that we saw before. So we got, given that AB is perpendicular to BF, RH is perpendicular to AF, angle 1 is congruent to angle 2. Can you prove that HR times BF is equal to BA times HA? Okay. As you can see, it's very similar. Right? Go ahead, everybody try. Of course, you could help each other out too, that's fine. Let me give you the first line for you. Given. Okay, so what do we do afterwards? Okay, how about Kristen? What are you going to say next? Angle B and? Angle HR? Right angles. Yeah, instead of saying H, I'm going to say RHA. Is that okay? Because H. But yeah, that's what I wrote. So because of definition of perpendicular lines, right? So we say they're right angles, and then you say what? Because 90, their right angles are 90. Definition. And what do we know? If they're both 90, the two angles are what, guys? Because I forgot that step. So what do I write next? How about Chris? Shh. Chris? What do you say? After we know that they're both 90, what do you know about these two angles? These two angles are? Right, Chris? So they're congruent, right? Now, we have two angles congruent. Two pairs of angles. 1 and 2. RHA and FBA. What do you know about these two triangles? These are similar. By the way, does the order matter? RHA and then ABF? Okay, it does matter. You have to use the corresponding vertices, right? Otherwise, it's wrong. Then, now, this is the important part. Listen. We want to show something about RH, BF, and BA and HA, right? So, which pairs are we going to say they're in proportion? Yes.
HR
Good.
BA equals HA over BF.
There you go. We want to say something about HR over BA and HA over BF. We don't need the other sides, do we? Because we're going to say something about these four pairs of segments, correct?
Yes.
These four pairs of sides. So then, of course, after this, we could use the property of proportion to say what? HR times BF equals to? Exactly. Isn't that what we wanted to say? Does that make sense? Do you understand? Do you see how this is very similar to the one we just did? Yes? Do you see why I chose these corresponding sides?
Yeah.
Right? How come I didn't use the other sides? Because yeah, that's not we're not talking about anything about the other side.
Wait.
Yes.
2.5.
Oh, because I skipped that. Yeah, I forgot to write down
What's
the step. Alright. Any question? Does that make sense? Okay, I'll give you time to write. Okay. So, take a look at example 3. Are these two triangles similar? But first of all, do you guys even see two triangles?
Wait,
Look, yeah, look at the one inside. Okay, look, ABC. Look at triangle ABC, right? I'm talking about triangle ABC and the big one. Okay. Are these two triangles similar? Raise your hand if you think they are similar. Raise your hand if you think they're not similar.
Oh, they are.
Again, how many? Raise your hand. Okay.
They are.
Okay, I want you to discuss. I'll give you some time. So you guys are correct. These two triangles are similar. Because, guys, because they're sharing that angle A. And angle C is congruent to angle D right there, right? Now, so here. What are you going to say? Angle triangle ABC is similar to what? Is it angle triangle AFD or is it ADF?
No,
Yeah, be careful. It is AFD, right? Please be careful. On your homework, if you mess up the order, it's not, or on the test, if you don't, right? Put the corresponding vertices correctly, it's wrong. Yeah. We'll see. No, it's the whole thing's off. Does that make sense?
Yeah.
So look at example 4. Look. We have two similar triangles, don't we? The small one and the Big one, because you have two parallel lines cut by a transversal, corresponding angles are congruent. Also, they're sharing the same angle. Now, in order to find x though, x is this segment right here, the small one. Can I do 3 to 1 as to 5 to x? No. That's what a lot of people would do. That's how you get it wrong. You have to compare the similar triangles. There are, right, corresponding parts of, corresponding sides of similar triangles. So it should be 3 to, not 1, but 3 to 3 to 4 as to what? 5 to? Is it x or 5 plus x? Okay, please be careful. Okay, it's 5 plus x. Yeah, the whole thing is 5 plus x, isn't it? Does that make sense? You gotta compare the small one with the big one, like this. Right, guys? This is 3 to 4 as to 5 to 5 plus x. Does this make sense? Right? Does that make sense? Yes? Hello? Okay. Any question on these? Can you do something like this for your homework tonight? Have a great day, guys.